Hi guys. Good night everybody. Um, so I started working the solutions for the January 2023 paper, right? And there was one particular question that I want to make a correction to, right? Now this one has to do with the transformation question, right? Let me get this up here. All right, now one of the questions, right, they ask us to describe one transformation that maps P to Q, right? And we already can tell that Q was an enlargement of the quadrilateral P. Now, in the case of mapping P onto R, right? Now, if you notice the shape of P, right, and the shape R, they are congruent. They are identical, right? P and R are identical, so they are congruent. Now, if you notice R, the orientation of R has changed. Now, since the orientation has changed, right, there is a good chance that that transformation that maps P to R is going to be a rotation, right? Now, in this particular case here, you need to figure out where is the center of rotation because that is required in order for you to get the mark for this particular question, right? So here's what I'm going to do. The first thing I need to do, I need to join, let's see, let me join this point here, which would have been, one sec. All right, so I'm going to join 2 points that are supposed to be corresponding points, right? One sec. All right, so I'm going to join this to this point here, right? That is essentially the top of the quadrilateral in P, right? And I'm joining that to the top of the quadrilateral in Q. The next thing I'm going to do, I'm going to draw a second line. So let's go with maybe green this time. And I'm going to join, let's say, let me shorten this a little bit. Maybe right. So essentially what I've done, I've joined corresponding points on my object and my image, right? Now, the purpose for doing this is to try to locate where is the center of rotation, right? Now, to do this, I'm going to use my compass in order to do that, right? So in the exam, this is what you would have had to use, right? So let's say I have my compass here. What I'm going to do for each of those lines, the red line and the green line, what I'm going to do, I'm going to find my perpendicular bisector of each of those lines. Now, where those perpendicular bisectors intersect, that is going to give me my center of rotation, right? So let's start with this. Let me start with the red line and let me figure out where is my center, sorry, where is my perpendicular bisector, right? So hold on one sec. Right, so I need to open the compass to more than half the length of that red line, right? So I'm going to draw an arc, right? So that's one arc. Now I'm going to keep my compass open at the same width, but I'm coming on this side now, and I'm going to draw a second arc, right? So that's it. So if I were to draw a line, right, that passes through those 2 points of intersection there of the 2 arcs, that's going to give me my perpendicular bisector for that line, right? So hold on. Right? So all I'm going to do, I'm going to draw my perpendicular bisector here, right? So that line is the perpendicular bisector for that red line, right? So that's step one. The next thing I need to do now, I need to find the perpendicular bisector of the green line, right? So let's take our compass again. And what I'm going to do, let me just rotate this a little bit. Right, shorten this, doesn't have to be that long, right? And what I'm going to do now, I'm going to find the perpendicular bisector of that green line, right? So this is what I'm going to do. I'm going to draw an arc here. Taking that same width, I'm going to come across to this side, right? And I'm going to draw a second arc here. Right? So let's draw a line passing through those two arcs. Right? Now, we have to watch to see where these two perpendicular bisectors intersect. Now, I know the diagram may be looking a little confusing, but if you look carefully, now look at the lines that we need to pay attention to. This was one perpendicular bisector here, this line here, right? And the second perpendicular bisector was this line here. So we're looking to see where those two lines intersect. And if you notice here, they are intersecting at this point here, -4, 2. That particular point there is what we call my center of rotation, right? That's what we call the center of rotation here. Now, I've done something here so that you can see exactly what I'm referring to when it comes to the center of rotation, right? Now, let's check something here. So let's close U and let's open U, right? Now, what I have here, I have the triangle, sorry, I keep saying triangle. I have the quadrilateral P and I have R. So in the exam question, they gave you P, right? This was P across here. And then we had R here. And the question was to describe the transformation, the single transformation that maps P onto R, right? Now, based on our analysis just now there, we could have assumed, right, because the orientation has changed, but P and R are congruent, it has to be a rotation. So what I just did, I used geometry in order to figure out the center of rotation. So we got a center of rotation of -4, 2. Now watch carefully what's going to happen here. What I'm going to do, I'm going to demonstrate, I'm going to use the point -4, 2 as my center of rotation, and I'm going to rotate that quadrilateral. Let's see if the quadrilateral lines up, if the quadrilateral P lines up with R. Watch carefully what happens to that quadrilateral there. As I move it, I'm rotating it, right? I'm also showing you the angle as well. Watch. When I rotate it, eventually, it's going to line up exactly where R is, right? And if you notice, we've actually moved through 90 degrees. So the transformation that fully maps quadrilateral P onto R is rotation. So you need to specify it's a rotation. You need to specify the center of rotation as being -4, 2. And also, you need to indicate if it's clockwise or anti-clockwise. So here's what the answer is supposed to be. It's a rotation anti-clockwise, 90 degrees, about the point -4, 2, right? So that is a correction that I wanted to make because the original paper that I had when I was doing the construction, right, I wasn't getting it to work out properly with the construction, right? So this is your answer for that particular question, all right? right, so I'm just going to wrap up the remaining questions that I had to do for you all, right? So I'd done up to question 7, right, previously, right? So I just want to do the last 3 questions for you guys, right? Let me get to that page. Okay, so we have the functions f, g, and h. So they gave us some definitions for some functions here. We have f, we have g, and we also have h here, right? And they want us to find g of x minus 2. Now, g of x, right, is equal to x squared minus 5. And you want to work out g of x minus 2. All we're going to do here, guys, is substitute x minus 2 into the function g. So this is going to be x minus 2 squared minus 5. So when I expand x minus 2, that's going to be x squared minus 4x plus 4 minus 5. So this is going to be x squared minus 4x. 4 minus 5 is going to give you minus 1, right? So that's the answer for g of x minus 2. The next thing that we want to work out in part 2 is f inverse of 11, right? Now, f of x, what is f of x? F of x is 4x minus 1. So f of x is equal to 4x minus 1. So what I would do, I would actually find the inverse function first and then substitute 11 into that inverse function. So the step 1 here is going to be let y equal to 4x minus 1. Next thing we're going to do, we're going to interchange. So anywhere we see y, you're going to put x, and anywhere you see x, you're going to put y. So this is going to be 4y minus 1. So 4y minus 1 is equal to x. So 4y is equal to x plus 1, and y is equal to x plus 1 over 4, right? So what that means is that our inverse function, so f inverse x, right, is equal to x plus 1 over 4. So now we want to work out f inverse of 11. So this is going to be 11 plus 1 over 4. So that's 12 over 4. And that's going to give us 3. Right? So that's my answer for this one. In part B, you want to work out h of 1. Right? What is h? Alright, h of x is 3 to the power x. So h of x is 3 to the power x. Right? Now, if you want to work out h of 1, this is what we call a composite function here. So what I would do, I would find h of 1 first. So this is going to be 3 to the power 1, which is going to be 3. Now, if you want to find h of 1, you're going to take that answer and substitute it into h again. So h of 1, right? All you're doing, you're taking this answer you just got here, and you're going to substitute it as x across here. So this is going to be 3 to the power 3, or 3 cubed, which is going to be 27, right? So that is what h of 1 is going to be. All right, so let's see what the next part of the question is now. So this next part here, we want to, a function f, so they give us a function, and just by looking at the function, we can tell it's a quadratic. And what they want us to do is to complete this table. So this here is my function, and I need to substitute minus 2 into that function in order to figure out what to put in the table. So I'm going to work out f of minus 2. So that is going to be minus 2 squared minus 2 minus 2. Minus 2 squared is 4. Minus minus 2 is the same as saying plus 2 minus 2. So this here is going to give me 4. So this here is going to be 4. Next thing we need to do, we need to find f of 0. So f of 0 is going to be 0 squared minus 0 minus 2. So this is going to be 0 minus 0 minus 2. So this here is going to be minus 2. So this here is minus 2, right? So we're getting some marks just to complete the table. And I noticed they gave a lot of marks here to draw the graph, right? They gave them a lot of marks to draw the graph. They said using a scale of 2 cm to represent 1 unit on both axes, right? So we have to follow the same scale that they want us to use. So this is 0, right? 2 cm to 1 unit, right? 2 cm to 1 unit. So this is going to be 1 here. This is going to be 2 here. Let's see what my numbers look like. You went from minus 2 to 3. So this one is going to be 3. This here is minus 1. And this here is minus 2. Across here it'll be 1, 2, 3, 4. This is going to be minus 1, minus 1, and this one here is going to be minus 2, right? Now all we need to do now is to plot the points. So the first one will be minus 2, 4. Minus 2, 4 is going to be up here, right? So this is the first point I need to plot, minus 2, 4. The second point is minus 1, 0. So minus 1 and 0 is down here, right? The next one is 0 minus 2. So 0 minus 2 is down here. Next one is 1 minus 2. 1 minus 2 is down here. Next one is 2 against 0 and then 3 against 4. So 2 against 0 is here and then 3 against 4, right? So you're getting marks for plotting the graph accurately, plotting the points. And the next thing now is for us to sketch this thing, right? Now it's a little hard for me to sketch it here, right? Because it's not on a piece of paper I'm writing on here, right? But it's a quadratic and it's going to have a minimum point. Right? And also we never use a ruler when you're drawing this curve, right? It is a curve. You are not using your ruler to join the points, right? You're trying to draw a nice, neat, smooth curve. That's essentially what it is, right? So this here represents my quadratic, right? Right, so that takes care of question 8. Moving on to question 9 now. So we have a circle geometry question here. We have W, X, U are points on the circumference of a circle. TV is a tangent to the circle. UW is the diameter, right? And they told us that the triangle is isosceles. Using appropriate theorems, state 3 reasons and explain the measure angle Z is 45. So they want 3 reasons. First things first, since WU is a diameter, that tells me something. That tells me that this angle here has to be a right angle or it's 90 degrees. So that's rule number 1, right? Since, what do they call this? WU is a diameter, right? What do I call that angle there? WXU has to be equal to 90 degrees, right? And since they want you to state a theorem, all we need to say is that the angle in a semicircle is 90 degrees, right? So the angle in a semicircle is 90 degrees. So that's one thing we can say so far. We know that this angle here is 90 degrees. Now the next thing is that this triangle here is an isosceles triangle. So if that's an isosceles triangle, right, it means that this angle here and this angle here have to be the same angles, right? They are the same. So you're going to say, right, since triangle, what's that triangle? WXU, right, is isosceles, right? Angle UWX is going to be 180 minus 90 degrees divided by 2, right? So that's going to be 90 over 2, and that's going to be 45 degrees, right? So we know that this angle here has to be 45 degrees, right? Now, at this stage here, I can easily tell you that Z has to be 45, right? Now, there are two reasons or two different things we can say here. In the case of this line here, this line UX, that is called a chord, right? This here is called a chord. Now, there is a rule that involves a tangent and a chord. So this here, right, is a tangent. They told you that. So the angle between a tangent and a chord is equal to the angle in the alternate segment. This angle here, this 45, is the angle in the alternate segment. So we can say that as our third reason if we want. So XUV, right? Or we could say angle Z is equal to 45 degrees, right? And the reason why the angle between a tangent and a chord is equal to the angle in the alternate segment. Right? Now the thing is, there is another reason or another way we could have worked out that, right? And since we know that this angle here was 45, we know that this here is also 45 degrees. But the thing is, this line here is a diameter, and the angle between a diameter and a tangent is 90 degrees. So what we know is that this here is your diameter, this line here is your tangent, so this here would have been 90 degrees, right? So that's another way we could have gone. So there are actually more than 3 reasons, right? So that's my answer for that one. We have a part B here now. The diagram below shows a circle with diameter KF. EFG is a tangent, right? Okay, so they give us some information. They have a diagram there. What they want you to work out angle X and angle Y. Let's start with angle X. Now this line here, FH, is a chord, right? Now the thing is, if we form an angle on the circumference, which in this case is 56 degrees, and I would use the same point F and H and go on the circumference again, this angle here should also be 56 degrees. So angle X is equal to 56 degrees, and the reason that you're going to tell them is that angles in the same segment are equal. Right? So that's your reason for angle X. The next one that we need to work out what is Y. Now, working out Y is not too bad, because you know what angle X is, right? X is 56 degrees. This angle here is 19 degrees. All I really need to do here, guys, is to figure out what is this angle across here. That is this one. If I know this one here, I can easily figure out what Y is, because that's a triangle. So X, sorry, not X. let me call this XY. Let me call this P, right? I'm just giving it a label here. Let's call that P. Angle P is equal to 180 degrees minus 56 plus 19. So that's 180 minus that's 75. So that's 180 minus 75. And that's 105. Right? So that angle P there is 105. So now to figure out what is angle Y, right? Angle Y is simply going to be, right, 180 minus 105. Right? Because that's a straight angle, and a straight angle is 180 degrees. Right? So this here is going to be 75. Right, so what else we have here now? Right, so we worked out those angles. Then we have a part C now, which is based on, I guess, trigonometry. So we have 4 points here, PQ, R, and S on level ground, where pillars are to be placed to mark the outline for a foundation. Right, there's a vertical post RT at R. So what we're looking at here is a flat surface, right? We have a shape here, it's a flat surface. So let me see what's happening here. You have the point R is here. And we have a pole here, which we call an RT. And remember, PQ, R, and S are all on the same ground, right? So the angle of elevation from Q so this is the point Q here, right? Angle of elevation means that we're looking upwards. So you're looking upwards here towards this point T, and that angle there is 21 degrees. So this here is 21 degrees. That's my angle of elevation. Now, what I want us to do is to work out the height of the post. Now, the thing is, the distance between Q and R is 153 meters. So QR is 153 meters, and you want to get the height. Now, in terms of this triangle here, this here is my opposite. The 153 is your adjacent. So we have opposite, we have adjacent, so therefore we're going to be using tan. So you start off by saying tan theta is opposite over adjacent. So therefore tan 21 degrees is equal to TR, which is what you want to work out, over my adjacent, which is 153. We're going to cross multiply, so we'll get TR is equal to 153 multiplied by tan 21. And you're going to get around 58.7 meters. Alright, so that's the height of my post there. The next part, they said given that the length QS is 135, they want the perimeter of the foundation. So QS is 135. So that is, this length here is 135. Right? Now, if you look carefully, we have this here, 83, we have 153, we have 110. So the only length that we're missing in order to get this perimeter is PS. So you have to look and see what rule can I use in order to figure out PS. Now the thing is, it's not a right angle triangle, right? But we have two lengths and we have the angle between those two lengths. So the only time you, or the formula that we're going to use the cosine rule, right? So when I use the cosine rule, it is going to be, let's just write down what the cosine rule is first. So C squared is equal to a squared plus b squared minus 2ab cosine c, right? Now c is the side opposite the angle that we want to work out, which in this case is PS. So this is going to be PS squared is equal to, now the length of the other two sides will be 83 and 135. So this is 83 squared plus 135 squared minus 2 by 83 by 135 by cosine my angle, which was 29, right? So therefore PS squared is equal to, now I'm going to just work this out in one go, right? So 83 squared plus 135 squared minus, open brackets, 2 by 83 by 135 by cosine 29, close brackets, and I'm going to get 5,514. So therefore PS is equal to the square root of 5514. So PS is equal to, and that's going to be 75, around 75.3. Sorry, 74.3 meters, right? So the last thing that we need to do now is to find the perimeter. So the perimeter is simply going to be equal to, all we're going to do is add up all the dimensions. So 83, 153, and 110. 83 plus 153 plus 110 plus 74.3. And when I add this up, I'm going to get my perimeter. You're going to get about 420.3. All right, so we just have the last question to do now, and that is on vectors and matrices. So we have three matrices, Q, R, and S. Explain why matrix QS is not possible, right? Now, to do that, the order, we need to talk about the order. So the order of Q, right? That's how many rows and how many columns I have. In Q, I have 2 rows and I have 2 columns. We need to know about the order of S. In the case of S, I have 3 rows and I have 2 columns. Now, in an order for 2 matrices to be able to be multiplied, this number here and this number here needs to be the same, right? They need to be conformable, right? This 2 has to be the same. If they are different, you cannot multiply the matrix. So when we say explain why the matrix QS is not possible, is that you're going to say the number, right, of columns in Q is not the same number of rows in S, right? And that's the reason. That's why you can't multiply them, right? They must be the same number, right? The next one, we want to state the order of the matrix S by R. Now, matrix S is a 3 by 2 matrix. So S is a 3 by 2 matrix, and you're multiplying that by matrix R, which is, R is a 2 by 2, right? R is a 2 by 2. Now, when you multiply these 2 matrices, right, your final answer, or the order of your final answer, SR, is going to be this amount of rows and this amount of columns. So therefore, you are going to get a 3 by 2 matrix. So this here is your answer. You're going to get a 3 by 2 matrix as your answer. And the next thing they want us to work out is QR, right? Now, what is QR again? So Q is 2 minus 143. Right, that's Q, 2 minus 143. And R is 1, 6 minus 5, 4. R is 1, 6 minus 5, 4. Right. 1, 6 minus 5, 4. Now, you need to remember, right, you're going to get a 2 by 2 matrix as your answer. So let's call this E11, E12, E21, and E22, right? Now, the reason why I normally write it like this is so that students know exactly what they're going to multiply. So E11, right, is going to be, you're going to take row by column. That's a key thing to remember here. This row by this column, right? So that's going to be 2 by 1 plus minus 1 by minus 5. So this is going to be 2 plus minus 1 by minus 5 is 5. So this is going to be 7. Then I'm going to work out E12, right? Again, row by column. So that's 2 by 6 plus minus 1 by 4. So this is 2 6s 12 plus minus 4. That's going to be 8. And then we need to work out E21. So that's row by column again. This row by this column. So that's 4 by 1 plus 3 by minus 5. So that's going to be 4 plus 3 by minus 5 is minus 15, right? So that is going to be 4 minus 15. You're going to get minus 11. And the last one, E22, you're going to do row by column again. So that's 4 by 6 plus 3 by 4. So that's 6 4s are 24 plus 3 4s are 12. So that's going to be 36. So your answer is going to be 7, 8 minus 11, 36. Let's hope that's correct. Hopefully I don't have an error there. Alright guys, so don't forget, hit like and subscribe, right? Alright, what else we have to do here? Okay, so they gave us a matrix A, and they said so what they're telling us is that the determinant of this matrix is 5, right? Now, the determinant, what we do, we take this and multiply by this, first of all. So that's 4 by x minus, then we have to take this and multiply by this. So that's going to be minus 1 multiplied by minus 7. But it told us the determinant is 5. So that's 4x minus 1 by 7 is going to give me 7 equal to 5. 4x is equal to 5 plus 7. 4x is equal to 12. And therefore x is 12 over 4. So x is equal to 3. Right? So that's my matrix part of this question here. We just have one more part to do, and that's the vector part of this question. So we have a diagram here, right? Right, some information, blah, 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 blah. All right, B is the midpoint. So we're looking at the important things here. B is the midpoint of P and Q. R is the midpoint of AB. Where's R? Okay, so this is R here, right? Those things are going to be important at some point. The ratio OR to RP. OR to RP is 1 to 3. Okay. And OP is 4A. Okay, I need to write down some of these things, right? So OP is 4A and OQ is 8B. Okay. Now the first thing that we want to figure out what is PQ. So let's look at the diagram. We want to figure out what is PQ. All right, well, that should be easy enough. So PQ, right? You want to start at P and you want to end up at Q. So the route that I'm going to take to get there is going to be PO plus OQ, right? So PO, right, is the reverse of this vector. So it's going to be minus 4A plus OQ, which is 8B. Straightforward enough. That's it. That's all we need to do for that piece there. So the vector PQ is minus 4A plus 8B. That's it. So that's this. Next thing we want to work out PR. Where's PR now? So PR, right, is this vector here, right? So you want to go from this point and you want to end up here, right? Now let's see what can we do. All right, so the vector OP is equal to 4A. So the vector PO, right, is equal to minus 4A. Now they gave us a ratio here of where the point R is, right? Now the ratio of OR to RP, right, is 1 to 3. So that means that this length here, right, we're dividing up the line OP into 4 equal parts. Whenever they give you a ratio like this ratio is 1 to 3, I'm dividing that full length OP into 4 equal parts, right? So therefore, this line RP could be divided up into 3 equal parts, and this here is your 4th part, right? So the vector, something, PR, that's what you want to work out. So PR, right, is simply going to be, based on the information we have here, PR is actually 3/4, right, of the vector PO. Hope that makes some sense. Right? Based on the position of R, they told me that the ratio OR to RP is 1 to 3. So what I'm doing, I'm dividing the line PO into 4 equal parts. So that means that PR is actually 3/4 of PO. So this is going to be 3/4 multiplied by PO, which is minus 4A. So therefore, this here is going to be minus 3A. Right? So that is PR. So that's this. And the last thing that we want now is RB. Let's see where RB is now. All right, so RB is this vector here, right? RB is that vector. If you want to go from R to B, then you can go from R to P, right? And then P to B. So let me write that out. RB is equal to RP plus PB. Now RP, what is RP? Well, RP is the reverse of this. RP is actually equal to 3A plus PB. Now the thing is, PB, as this vector here, right? Remember, this point B is the midpoint of PQ, right? So PB is actually a half PQ. So this is a half PQ. So this is going to be 3A plus a half. And we worked out PQ in the first part. We got minus 4A plus 8B. So this is going to be 3A minus 2A plus 4B. When I simplify this, I'm going to get 3A minus 2A is A plus 4B. right? So that's my vector RB, right? Now, overall, right? Overall, this paper was reasonably pretty easy compared to the last exam paper, right? This paper was pretty easy, right? All right, guys. So I just wanted to complete the paper that I started previously, right? Hope to go live some other time, right? So if you haven't done so as yet, guys, please hit like and subscribe. That's it for me for tonight, guys. Later.